Okay, here's a review of the Quantum DX Loop version 3 from Radio Plus DX Tools. I purchased a unit with the base and 3 loop heads. There's one loop head for medium wave, there's a loop head for long wave, and there's a loop head for short wave. Each of these loop heads simply pops in and out of the base. Can be rotated 360 degrees, and it can also be angled like this to peak the desired signal or to null out interfering signals. The base unit has a power switch, can be run off of a wall wart or a battery. I'm using AA's, 8 of them, or there's a connector holder for a 9-volt in the back. So different options can be used. You have a gain control, the tuning knob, switch which allows you to put the performance on the low, medium, or high portions of a particular band. And you also have what's called a regenerative function, which feeds back into the system the received signal, and it helps peak it to aid with reception. And then there's also a knob here that's called a Q spoiler that allows you to broaden the pass band a bit when you have a lot of regeneration going on. So the setup I'm going to demonstrate is the quantum loop antenna feeding into what's called a quantum phaser, which is a phasing box developed by Radio Plus DX Tools. I've had this for a while. Both these products have been sold for many years, and there's better reviews, more critical reviews by more serious shortwave listeners than me, and all of those rave about the performance of these two tools for serious midwave and shortwave DXing. But the quantum phaser allows you to take 2 inputs from 2 different antennas. They can be any type of antenna, loops, wires, whatever, and phase control them so that the signals create a more powerful directional array, if you will, to allow you to peak the signal or null the signal. Allows you to control amplitude for the 2 different inputs. Can be powered off a battery or a wall wart. Allows you to sum the 2 signals, switch between the 2 signals or input ports or antennas, and then phase them. So for this review demonstration, I'm going to feed the quantum loop into one port, and then over here I'm going to feed in the Crane twin coil medium wave antenna. It's also a ferrite loop with directional properties similar to the quantum loop, essentially bidirectional. So it's Litz wire wrapped around ferrite material. So that will feed into the phaser with the quantum loop. And then the receiver that we're using is the PL660, a very proven short wave and medium wave receiver. Now, this doesn't have an input port, so we have to use a coupling box from the output of the quantum phaser, and this coupling box just inductively couples into the internal ferrite antenna of the PL660. So I'll demonstrate reception of an AM signal without any aid from either antenna, and then I'll switch between the quantum and the Crane, and then I'll try to sum the 2 together and see how much improvement we get. So we're going to go ahead and set up here. Okay. So right now we have the quantum loop fed into the phaser, but only the quantum loop selected. Coupling box going into the PL660. And right now you're listening to a station, 540 AM, I believe it's up in Wisconsin. And if you listen very carefully, it's coming in, but there's actually 2 signals, a woman's voice and a man's voice. Now I will turn on the quantum loop Now that's the crane twin core loop. Internal. The twin core. Now that's the quantum loop. Quantum loop. Internal. Quantum loop. Crane twin core. Quantum loop. Twin crane. Let's try to phase them. Now both antennas are phased together. Now let's turn it off. Big difference. One antenna, that's the crane. Quantum loop. Both. None. Internal antenna. Internal antenna. Both the quantum loop and the crane phased. Quantum loop. Twin core. Both. Now I'm going to shift the phase. You can see it get better. To me, he did Oklahoma a favor. Did Buddy feel he was 4 of 11? Stop shooting? No. He drove 7 of 10. Okay, here's another AM station 580. There is some interference from the camera, but I think you can see how the quantum loop enhances the signal versus the internal loop. So this is what the quantum loop tuned. And here's the internal. Barely audible. Loop on. Now let's compare it to the crane. Let's tune in the crane. That's the crane. Quantum loop. Crane. Quantum loop. Internal. Now we're going to try to phase them together. Look at that. Now I'm inverting the phase. Internal antenna. The CC crane twin core phase with the quantum. Internal antenna. Now I'm going to switch back to the crane. Quantum loop. It's much more stable, less fading when they're phased together. Okay, we've replaced the quantum loop head from the medium wave to the short wave, and I have the PL 660 tuned to the amateur band, 160 meter. There's a contest going on right now, and you're receiving it on the internal whip. And I don't know if you can see it, but on the strength bar, barely over 1. It's receiving them, but not very strong. Now I'm going to connect the output of the phaser. That's the internal loop head, and we have pegged it all the way to 5. When you plug it into the port, the internal antenna is disconnected, and we are now running from the quantum loop. You can see the directional properties of the loop head. So let's try to demonstrate the this is running off the loop. That's the internal antenna. Big difference. That signal right there, that's off, peaked. So it's a pretty compact solution for shortwave DXing on the road. Now what I'll do is I will connect up the K2 KA33 loop antenna, and we'll do a comparison between that and the quantum loop on the amateur band. Now we're going to demonstrate the quantum loop fed into the phaser, and then the K2 KA33 active loop antenna, which you can see on the back wall there. That's my cat Walter checking it all out, trying to wake up. But anyway, there's the loop, and that is being fed into port B on the phaser, and port A has the quantum loop. So we're going to demonstrate the difference in performance between the two. So right now we're on the quantum loop. Nice strong signal. Now we're going to switch. That's the K2. Now in fairness, I'm not changing the orientation of it. But this little unit allows you to peak it. Back to the quantum. Quantum's a little better. Now we'll try to phase them together. It's My cat, he loves boxes. He has a box fetish. Not much difference in phasing. I suspect if you got the antenna separated closer to a quarter wavelength, which is quite a distance given the frequency we're operating on here, you'd be able to phase and see a big difference. Now we're going to go back to the internal antenna. Barely any reception. No reception, frankly. Well, you got to disconnect it. There you go. Internal antenna, shortwave antenna on the PL660. And that's back to the Quantum and the KA33 loop. So, kind of hard to see here, but this is the signal bar. This is my other cat, Oliver. But you can see we're consistently running about a 4, and that's the KA33 phase with the Quantum loop. Now I'm going to switch between the two. About a 3 on the KA33 loop. Now back to the Quantum. A little bit better, but a lot of fade. Now we're going to phase the two together. Consistently a 4. At times hitting a 5. So the phasing definitely makes a difference. Feeding the two outputs of the signal in phase to achieve a stronger signal level. So, that's the Quantum loop, the Quantum phaser, PL660. We showed the performance on the medium wave, Crane twin core versus the Quantum loop. And I would say, in my opinion, the Quantum loop offered a little better performance, and it's a much smaller package, easier to adjust the directionality, gives you a few more features. Then we compared the Quantum loop, changing the loop head to shortwave, to the KA33 through the phaser box versus the internal antenna. In all cases, the Quantum loop enhanced the performance, receive performance of the PL660 versus its internal ferrite on medium wave and its external antenna on shortwave. So if you're planning to travel and do DXing, I think the Quantum loop offers some nice features, gives you specific loop heads for specific bands to enhance performance, can run on batteries. And if you're really serious, you add the phaser to that, and you can use different antennas and ways to enhance the reception. The other nice thing about the Quantum loop, if you look under here, it's got a binding post that allows you to feed a wire antenna into it, such as a bog, beverage on the ground, or just a random length wire, or high performance, low noise antenna, and use the base unit of the Quantum loop to pre-select and add gain to the external antenna. So if you couple that with the phaser box, you really get a pretty powerful, sophisticated shortwave DXing system. And this will work with pretty much any receiver that has an external port. So that's the review. Comments or questions, please let me know. Thanks.